today on language of chemistry chapter according to ICSE syllabus. My last video I have not received any of your answers. I'll be discussing the question answers, practice question answers. Okay. And later on, after completing this one, I'll start in my next video the question answers, rather the all the question answers of the book, and also some other places I have collected for you to discuss, so that you can understand the chapter better. Okay, and that will help you in your examinations. Okay. So today, before starting, I'll ask you to please go through the text videos and do stay tuned with me so that you can understand, and also you can follow the question answers which I'm discussing with you, and also the chapters which I'll be continuing with later on. So for that, you need to subscribe, and also do press the like button, and also share with your friends so that they can also be benefited from these videos. And let me start with the chapter today, that is the question answers, which the practice question answers which I'm going to discuss today. Okay. So what do the following symbols stands for? H, H2, 2H, and 2H2O. Sorry, 2H2. So first one, H is hydrogen atom. Second, H2 is dihydrogen or hydrogen gas. 2H is two hydrogen atoms, and 2H2 is two dihydrogen molecules. Okay. Then give the chemical name of the following compound: NaClO, NaClO3, NaClO2, NaClO4. See, NaClO is sodium hypochlorite. Okay, how this name comes from? Hypochlorite, when it has the lowest valency, the oxygen, the non-metal, when the compound has two non-metals and one non-metal, that oxygen compound, oxygen non-metal will be having the valency which is less than 3, less than 2, rather less than 2, then it is hypochlorite. See, a sodium hypochlorite. Okay, when it is 3 oxygen, if it is the number of atoms is 3, then it's sodium chlorate. Chlorate it becomes 8 is suffix is added to it. Then if it is O2, that is 2 atoms are there, then it is ite, chlorite, sodium chlorite. And if it is more than 3, then the prefix is added, that is perchlorate. Okay, chlorate is there, but perchlorate. Okay. Next, excuse me. Give the name of the following compounds: HNO2, PbNO3 whole twice, KMNO4, H2SO3, NaH whole twice, Pb, COCl2, AlPO4. So HNO2 is nitrous acid. PbNO3 whole twice is lead nitrate. Valency of lead is 2 here, so lead nitrate. Then KMNO4, potassium permanganate. Okay. Then H2SO3, CH3 whole twice Pb, that is lead acetate. NaCl3, sodium bicarbonate. COCl2, it's cobalt 2 chloride of common name, that's AlPO4, that's aluminium phosphate. Okay. Now we come to some of the fill in the blanks. These questions have come in your ICSE some years, and some have some practice mock test you can give. You can these questions are in the mock tests of yours, this syllabus, okay, class 9 syllabus. So mock practice questions you can call them. So please go through these questions, that will help you in your question solving in your exams also. Okay, so PL minus F minus which are dash sodium, calcium, these are positive radicals, or you can say basic radicals. Chlorine, chlorine, and carbonate radicals, these are now Hg represents what? Mercury. Chemical formula of carbon dioxide is CO2. Then the molecular formula of ammonium sulfate. The options, see, the two options are given. That is NH4SO4 or NH4 hold twice SO4. NH4 has one valency. The radical NH4 has one valency, and sulfate SO4 radical has two valency. So the formula will be NH4 hold twice SO4. Okay. So next I'm going to write the symbol for gold, lead, mercury, and silver. Gold is AU, lead is PB, mercury AG, silver is AG. Now define variable valency with two examples. See, I have told you when when I was discussing the chapter in my chapters videos. So I've told you that variable valency is a valency where some elements, what happens, certain elements, they exhibit more than one valency because they lose electrons not only from their this ultimate cell, that is the last cell, also from the penultimate cell also. Okay, so that makes the variable valency for the elements. Therefore, for example, see lead, which we call them as plumbum. Okay, that exhibits two valency. One is +2 and another is +4. Okay, why plus? Because it's a basic radical. Okay, this is a metal, it will lose electrons. That's why it is, if it loses electrons, then it becomes plus, positive cation. Okay, then the lower valency Pb2 plus is plumbus or lead 2. The higher valency is Pb4 plus, or we can call it plumbic or lead 4. Okay. Next is the iron, ferrum, exhibits two valencies, +2 and +3. The lower valency is Fe2 plus of ferrous or iron, we can say iron 2. Then the higher valency is Fe3 plus ferric or iron 3. Okay. Now each question has 4 options, out of which only one option is correct. Write the correct answer. The formula of ferric sulfate, ferric means it has 3 valency and sulfate has 2 valency. So what will be the formula? Fe2, we exchange the valencies. No, when we make a compound, and put the valencies, we exchange the valencies of the acid and the basic radical. So the correct option will be Fe2SO4 whole thrice. Okay. Next, the symbol for nitrate ion. Nitrate radical is NO3, and nitrate ion has a valency of 1. Okay, as it is a negative radical, so it will be the NO3 minus will be the symbol of the nitrate ion. The formula for magnesium nitride is Mg3N2, magnesium nitride. Magnesium has a valency of 2, nitride has a valency of 3. Okay, so when exchanging the valencies, it will come to Mg3N2. The valency of iron is FeO. In FeO is what? iron, see, Fe and O both have the same valencies. That's why their valencies are not written here. Okay, so both the cases, Fe and O has two valencies. So the correct option is +2. Okay, the formula of two chlorides of phosphorus are PCl2 and PCl3. This will be the correct because phosphorus has 2 and 3 valencies. So other C, PCl3, PCl4, PCl3, PCl5, PCl, PCl2. So first option will be correct. Two chlorides of phosphoruses will be PCl2 and PCl3. Next is the formula of chloride of metal M. It's a given metal M. The formula is written as MCl2. So what will be the valency of M? M with the valency. We know chloride has one valency. So M will be two valencies. M will be having two valencies. So what will be the formula of it when we are combining with carbonate, M with carbonate, M with nitrate, and M with hydroxide. So the formula will come to MCO3 because M has two valencies and CO3 also, that is carbonate, has two valencies. So MCO3. Nitrate has one valency. See, MNO3 whole twice it will be, not NO3, but NO3 whole twice. Okay, MNO3 whole twice. Then hydroxide, MOH whole twice. Okay, M hydroxide has two valencies. So MOH whole twice, and this will be B option, B1, that is nitrate, that will come to MNO3 whole twice. Okay, please correct it. Okay, deduce the molecular formula of the following: ammonium acetate, lead chromate, calcium carbide, aluminium carbide, and sodium bicarbonate. So ammonium acetate. Ammonium acetate is CH3COO, that is acetate radical, and NH4. Okay, how does it come to? Like, see, NH4 plus, this is the basic radical, and acetate radical, this acid radical is CH3COO. Now we exchange their position in valency. Sorry, not position. We exchange their valencies. So it will come to CH3COO NH4. Okay. Now next is lead chromate. Okay. Pb2 plus CrO4 2 minus. Okay. So Pb2, this has 2 plus and 2 minus. So we exchange this one. Valencies, it will come to PbCrO4. Okay, same valencies. So when we divide it with highest common this one factor, then it will come to 1. Okay, then again calcium carbide. Calcium carbide also Ca2 plus and C2 2 minus. Okay, carbide has a formula of C2 minus. So these two will be omitted, and the answer will be CaST2. Then Al3 plus, this one aluminium carbide. Aluminium carbide is Al3 plus C4 minus. So it will come to, I'm sorry, there's something calcium carbide, it will be CaC, okay, not C2, because carbide has a formula. I'm sorry, again, it will be C4 minus, okay. Carbide has a valency of 4 minus, so it will be Ca2C, not CaC2, but Ca2C, okay. There's again a mistake, please rectify it, please. It will be Ca2C. Okay, carbide has a valency of 4 minus. Okay, so the formula will be Ca2C. Okay, and then next is aluminium carbide, aluminium 3 plus, carbide C4 minus. So the by exchanging their valencies, it will come to Al4C3. Okay, Then Na plus HCO3 minus, it will be coming as NaHCO3. See, in this calcium carbide, the calcium has 2 valency and it has 4 valency. So when we exchange it and divide with highest common factor, it will come to Ca2C. Okay. Now define valency. How many valence electrons are present in fluorine, carbon, oxygen, and calcium? So first is define valency. What is valency? Valency is the combining capacity of an atom or a radical. How many atoms it can combine. Okay. It can combine, and that is, it's a combining capacity of an atom and a radical or a radical. In case of fluorine, the valence electrons will be 7 electrons. Then for carbon, it's 4 electrons, oxygen 6, and calcium 2 electrons, and their outermost shell. Those are called valence electrons. Then state the valency and the formula of the following radicals: phosphide, plumbous, mercuric, manganate, silicate. Phosphide 3 minus. Okay. Plumbous, that is lead. So it will be 2 plus. Mercuric 2 plus. Manganate MnO4 2 minus. Okay. Silicate, then SiO3 2 minus. So this is about all the practice questions. These are the questions I told you. These have come in some exams, and also these are some mock practice questions. Okay. So practice these and rectify these 2 questions, which there's some mistake in that. So please do rectify and forgive me for making a mistake. Okay. And do stay tuned with me. So follow the question answers and the chapters which are yet to come. Okay. And hope you are liking the videos. Press the like button. Do share with your friends and colleagues so that they can also be benefited from these videos. Thank you. Thank you for watching and have a good day. Thank you.